Hello, Maurieo! Maurieo reviews engineering math quiz 9. Hello. Well, in this video we're going to take a look at maths quiz 9 and what the implications of that is. So I've prepared some model answers for maths quiz 9. And we're going to take a run through them. So let's cut to the big screen. Here we go. And this is the model answers for Math Quiz 9. And let's start at question 1, the beginning. So let's examine the question. Differentiate the following functions. You do not need to simplify your answers. What we've been finding, we being the maths team, we have been finding that a number of people have actually got the correct answer and then in their attempts to simplify it have essentially got it wrong, the simplification wrong, and so taken an otherwise good answer and turned it into something not so good. So you don't need to simplify your answers. There are some little cosmetic things that we will do, but as a general rule you don't need to simplify them. Just get it to a reasonable point and stop. I guess determining what that reasonable point is the key to success. Alright, so in this first one we've got a function of t equals e to the negative 2t cos 3t. So what we have there is two functions essentially multiplied by each other, multiplied together. So we have e of 2t is one function and cos of 3t is another function. So they're multiplied together. So that tells me multiplication is the product rule. The product rule. So let's take a look at the product rule, and as you would find on your formula sheets. So I haven't actually got the formula sheet here. Just hang on a mo and I'll maybe I could just go away and find the formula sheet for you, and let's see if I can find it here. I know I've got it on Moodle. Reference materials. Oh, here it is. Formula sheet. Okay, so let's bring that over to here. Just for a view, so just so that we become familiar. So on the formula sheet we've got an area set aside for calculus, and here we have the function, the product rule, and here it is. Here I've written it out like this. So it says dy by dx equal, if you have two functions essentially y equals u dot v, then dy by dx equals u times the differentiation of v plus v times the differentiation of u with respect to x. And so yeah, you can see that, and it's plus. So, and here it is here expressed as differentiate y equals u times the differentiation of v plus v times the differentiation of u. So that's what I've written down there, and I'll just, so that's what I'm going to do. And then up here I've identified the two functions. So I've said u equals e to the negative 2t and v equals cos 3t. Now, in fact, if we want to find the differentiation of du by dt, that in itself is could possibly be determined a function of a function, and there essentially if we just go back to the formula, here we're actually performing this operation here. So where we're saying dy by dx equals dy by du dot du by dx there, and that's what's happening here. So du by dt equals, we differentiate negative 2t with respect to t, and that becomes negative 2, and e differentiated, just on its own, it just stays the same. So it's e negative 2t. So that's what's happened there. But they're quite simple ones and quite easy to remember. So yeah, you get negative, and here v, you get cos 3t. So differentiate the 3t, which is the 3, put that at the front, and then cos cos is negative sine, the differentiated. So we get the two ones there. So you could go a further step there and apply the function of a function rule there, but you should by now be quite familiar with doing that, and that shouldn't be a problem. However, if it is a problem, by all means just step back, take your time, and put those steps in there. Alright, so now we've got to bring it all together. So we've got u, which is e to the negative 2t, and then v dash, which is negative 3 sine 3t, plus cos 3t, which is v, here, v is cos 3t, and times v dash, which is cos u dash, v times this one. So that's negative 2 e to the negative 2t. Now they're all multiplied together, so just to get all the numbers and things in the right place. So here we can see that we've got negative 3, so that becomes negative 3 e to the negative 2t sine 3t, and there's a negative 2 there, and that becomes negative 2 e to the negative 2t cos 3t. So there it is. That's the first one sort of done. So by now you should be familiar enough to be able to do these ones off the bat, but as I say, if you do need to do them using the product, the function of a function rule, go for it. All right. Now the next one here, we can see that it's something over something. So quite clearly, it's the product rule. Let's just bring up our formula sheet. So here's our formula sheet, and it's continued down here. Bring up the formula sheet. So here we have the product rule. When we have two functions, the quotient rule. My mistake. So that's the quotient rule. Yes, I have got that right. Let's get the formula sheet back. The quotient rule says when y equals u over v. So one function u, then dy by dx equals v du by dx minus u dv by dx, no, it's minus, all over v squared. Okay, so let's pop that out of the way. So immediately what I do is I set up u and v. So I write them down. Let u equal that. Let v equal 2x plus 1. U dash equals 1 over x. If we differentiate that, anything log there, we get 1 over x. And 2x plus 1, if we differentiate that, we get v dash equals 4x. So now it's all done. It's just a matter of filling it in. So z dash, as we said, equals v u v dash all over v squared. Okay, so we can write that out quite simply. So we get 2x plus 1 in brackets, put that in a bracket, okay, times 1 over x, so I'll just put that in there, minus ln 4x, which is u, times v, which is v dash, which is 4x, all over v squared. V is 2x plus 1, all squared. Now you can, if you wish, just leave it there. That's fine. Some people have done a number of things with it. That's okay. So, and you've got 2x plus 1 all squared, and you've got a 2x plus 1 over there. So you could, and then you could put the x down on the, if you put these out individually, so you've got 2x squared plus 1 times 1 over x over 2x squared plus 1 squared minus ln 4x times 4x over 2x squared plus 1 all squared. If you wrote it out like that, then you can, as I see, there's the 4x, I've just brought that to the front, ln 4x over 2x squared plus 1 all squared minus, that's fine. Now here, then you could see that the put the x down onto the bottom, cross out that x and just leave the 1 there. So you get 1 over x bracket 2x squared plus 1 minus that there. Now both, you could stop here, that would be an acceptable answer. You could stop, you could carry on to here, and that would be an acceptable answer. So, but you know, if you're a little unsure, you know, about what's going on there, don't go there, just stop here. Remember, it says at the top, you do not need to simplify your answers. So why increase the risk of making a mistake? Leave your answers unsimplified. Okay, as the question says. Right, let's move on to question 3. And that's quite a question 1c. So that was 1b. The third question. Right, so we've got y equals bracket tan x minus 1 bracket cubed. So definitely what we have here is a function in a function. So we've got the tan 3x minus 1 is one sort of function, and then that's all cubed, which is another function. So it's sort of, in this case here, we've got some nested functions, because tan 3x minus 1 is also a function inside a function, and you've got 3x minus 1 inside the tan function. So we've got a series of nested functions here, and this is the chain rule. So I've proposed here to do it in 2 sort of steps. You probably could do it as a 3-step process, but I think it's probably easiest understood as 2 2-step processes. So first of all, let u equal tan 3x minus 1. Okay, so I've done that. And du by dx. Now, so what I've said is let u equal tan 3x minus 1. Okay, and then I want to find du by dx. So du by dx I'm going to do up here. But that is a function in a function because it's the 3x minus 1 in the tan function. So I've set let w equal 3x minus 1. Okay, so I've gone from here, I want to try and find du by dx. I realise that's a bit of a mission. So I'm going to go up to here. So let w equal 3x minus 1, dw by dx equals 3. Therefore, du by dx equals du by dw dot dw by dx. And so u equals, in this case, u equals, because we've got u equals tan x, so u equals tan w. Du by dw equals sec squared w, which equals sec squared 3x minus 1. Okay, so we're trying to find du by dx up here, and we let w equals 3x minus 1, dw by dx equals 3. Du by dx, which is what we're finding, equals du by dw dot dw by dx. So u equals tan w, du by dw equals sec squared w. So I've substituted w from here back in, sec squared 3x minus 1. So du by dx, I'm just restating this here, du by dw dot dw by dx. So du by dw is sec squared 3x minus 1, and dw by dx equals 3. So we get 3 sec squared 3x minus 1, which we write du by dx equals 3 sec squared 3x minus 1. dy by du, so we're back over here. So I went all the way over there just to do a separate du by dx for that little tan 3x bit. Now dy by du, that dy by du is what I'm finding. Dy equals u cubed, and y dash, which is dy by du, equals 3u squared. 3u squared. Okay. I should possibly, technically, I might just fix that while I'm doing this here. I think that there should in fact be just a y there. I'll just move that up there a little bit. Not only do you learn maths in these things, a little bit of key. Can I put a y in there? Yeah, I can. And a bit smaller. Control E is the key here. Control E. Come on, there we go. And that's way too big, so let's just make it 18. Okay, so y equals, yeah, there we go. Y, that's better. Y equals u cubed. Y dash equals 3u squared. Okay, differentiating that, which equals 3 tan 3x minus 1 all squared. Okay, so now we're going to put it all together. Dy by dx, which is what we were asked to find, equals du by dx dot dy by dx. So du by dx is 3 sec squared 3x minus 1, and dy by du, which is here, y dash dy by du equals 3 tan 3x minus 1 all squared, with a tan 3x minus 1 all squared. And I've put them in large square brackets. So then when we bring all that together, we get 9 sec squared brackets 3x minus 1 bracket tan 3x minus 1 all squared. Like that. That possibly could be written tan squared 3x minus 1. That I accepted that as well. So yeah, this in here should be dy by dx, but I don't think I can swing that just yet. Well, I could maybe put that in there. Let's go. dy dx. Oh, they should be lowercase. Is it dy by du? Should be dy by du, like that there, and they should be. Let's just make them 14. Yeah, and I don't know whether I can move them into the. Yeah, possibly. I'll just grab them like that there. Oh. Yeah. And that should be around about there. Perhaps I need to make these smaller. Oh. Here we go. They're at 14. I'll make them at 10. That's better. Just click out, right out there like that. Oh, here we go. We're getting almost there. Okay, so I can put that in there. And I just need to draw a line under it now, which will be a big fat line, I bet. Let's get some properties for that line. There's the line there. Right click, properties. Come on. Where's my line properties? Oh, 10 points. So something's gone wrong here. Oh, here we go. They're on my other screen. So I'll just drop that down to 1 point. Oh, 10 point, 1 point, and let's put them down to red. Okay, dy by du, that's better. Okay, dy by du, so that was y there, so I've changed that. I realised that possibly took an age, but you know, you might have learned something a little bit there about how to get that sorted, and you can see why. So here I had an improper statement. It wasn't dy by du, it's y equals that, equals u cubed, and then dy by du or y dash equals that, which equals that when you substitute the 3x, tan 3x minus 1 back in. All squared. All good. So that's that one there, done like that. Okay. So hopefully this one here, or this is a harder one again. So yeah, put that there. So using calculus, find the coordinates of all stationary points and determine their nature for the function. So it's to find the coordinates. So remember that a coordinate has a value, an x value, and then a y value, and they're shown in brackets, x and y. That is coordinates. So you've been thinking, why the hell is he telling me this? Well, that's because some of you did not find the y coordinate. Oops. Some of you did not find the y coordinate. Okay, oh, that should probably be a little bit bigger, perhaps just for emphasis, and it should be red. Okay, yep, okay. So remember, when it says coordinates, it wants coordinates, not just the x value. All right, so let's have a look. So we've got y equals 2x cubed plus x squared minus 8x plus 2. And the dy by dx equals 6x squared plus 2x minus 8. Pretty simple, really. There, you should be able to do these now pretty quickly. Now, dy by dx equals 0 at stationary points. So let's take our equation and set it to 0. 0 equals 6x squared plus 2x minus 8. Immediately we can see that 2 is common to all of those. So let's divide through by 2, and we get 3x squared plus x minus 4, which we can factorise reasonably easily. Okay, I made a small mistake early on, which I've since fixed. I had the x as a negative x. I don't know how I managed to do that, but I did. So that's why we've got some changes of sign. So we can factorise that quite simply. If we cannot factorise it, then yeah, so that should be, I've actually forgot to change my little thing here, so I'll just put a little line through there. That should be a minus. Oh dear. Okay, that should be maybe 3 points. Yeah, just to make that a minus, and it should be red. Okay, so that should be minus, and in here I'm just going to put a little oh, maybe I can do it here. Just put a little plus. Plus. Let's make that a bit bigger. Okay. Control E. Is that gonna do it? Doesn't look like it. Okay, so I'm going to make that a plus. I think you can see that because I've just got things a little bit wrong. So that should be yeah, 3x squared minus 3x plus 4x, which will give us a plus. All right, so we've got 3x plus 4 times x minus 1 are the factors. So either 3x plus 4 equals 0, in which case 3x equals negative 4, and x equals negative 4 on 3. Or x minus 1 equals 0, in which case x equals 1. So when x equals negative 4 on 3, we just put that back into the equation. That's the original equation, this one here. And so we get y equals 2 x cubed, which is negative 4 on 3 cubed, plus x squared, which is negative 4 on 3 squared, minus 8 times negative 4 on 3 plus 2. So we work that through there like so, converting everything to a common denominator of 27. So 9 goes into 27, 3 times 16 is 48 27ths. 3 goes into 27, 9 times 32 is 288, and that's 2 over 1, so that's 54 over 27. We add all that up, the tops anyway, because the bottoms are the same. 262 over 27 is 9.7037. So when x equals negative 4 on 3, y equals 262 over 27. These are the coordinates of the stationary point at negative 4 on 3. And then we do the same for the stationary point 1. When x equals 1, y equals 2x, 2 times 1 cubed plus 1 squared minus 8 times 1 plus 2, which is 2 plus 1 minus 8 plus 2 is negative 3. So the coordinates of the secondary stationary point at x equals 1 are 1, negative 3. So, and you'll see that I have 1, negative 3 there, and negative 4 over 3, 262 over 27 there. Now the question asks us to determine their nature. Okay, so that's when we do the second differential, and we know that if the second differential is positive, then we have a minimum. And if the second differential is negative, then we have a maximum. So let's have a look at negative 4 on 3. We put that into 12x plus 2, and that's going to be a negative all day. Okay, so we must have a maximum there. So we can say at negative 4 over 3, 262 over 27, we have a stationary point or turning point, it's a maximum. And then we can put when x equals 1 into the equation, and that's going to be positive all day, every day. So we can say we have a stationary point at 1, negative 3, and that's a minimum. And so there we have it, another little maths test that we've gone through very carefully. A couple of little adjustments along the way where you perhaps may have picked up a few tips on using Adobe Acrobat. However, the form I use of Adobe Acrobat is slightly different to the WinTech ones, but I'm sure most of the skills in that applies. So there we have it, Maths Quiz 9. Probably only got 2 more maths quizzes to go in this series, and then we'll be moving on to the real quiz, the exam at the end of the year. So a lot of these questions have been taken from exams past, so I'm going to say it again and again and again. If you are unable to answer these questions now, there is very little likelihood that going into the exam you will be able to answer the exact same questions, let alone similar questions that are slightly different. So first you need to be able to nail and answer these questions all day, every day, without too much hesitation. Determine your strategy, determine what you're going to do, find out exactly what it is you need, plan ahead, and get the job done. All good. Cheers. See you.